So going back to the beginning of the unit, we first talked about solving equations and then graphing them as a line graph and writing them as a, solution set notation, right? So we're going to do set notation here, and we're going to do a line graph. Okay, so solving is solving, and then plotting. Remember, I want the good points on there. Your answers are the only ones I really care about. And then write this notation as appropriate. So here is the answers to number 1 and 2. The actual answer, and then written as a line graph, and then written in set notation. Okay, so the next little section is all about finding domain. Okay, and hopefully you are more familiar with this now than you were 2 weeks ago. Right? There are only 2 things we need to worry about when we're finding domain. Anytime we have a rational function, the denominator can't be 0. So anytime you see an x in the denominator, like here, it can't be 0. This thing can't be 0. That thing can't be 0. In addition, anytime you have a radical, the radicand must be non-negative. So those are our 2 situations where we have to apply restrictions to your function. Okay, so let's do these 4 and find the domain of each of them. We'll be right back. And we're back with all the answers for A, B, C, and D. Okay? So notice on part C, because you can't be imaginary, that means you have to be real. So if you ever have a x cannot be an imaginary number, the answer is all reals for the domain. Okay, we spent a day or so talking about linear equations. Okay, point slope form. Remember some things. Here, let me remind you of some things. The slope of a line is found by y minus y over x minus x. And then point slope form is y minus y1 equals m times x minus x1. Okay, both of the ones on your test want you to write it in point slope form. So be aware of point slope form. And yes, we'll probably give you that formula on the test. I mean, it's not hard to memorize, but we're not going to require you to memorize it. So let's find the equation, and then let's find the one perpendicular through that given point. Okay, so try those, and we'll come back in another minute. So these are your 2 equations, or rather 3 equations, right, depending on how you write it. If you use the point 6 minus 3, then this is the equation you would write. And if you use the point negative 4, 2, this is the equation that you would write. They are both correct. And then this is the equation through the point 0, 6 with a perpendicular slope. So we had a negative 1/2. The perpendicular to that is positive 2. And there you go. Okay, a couple of writing equation things. Let's see, what else do we have on here? Some combinations, compositions, and inverses. So you have to know when to do which and which to do what. And we'll talk a little bit about the domain also here in a second. Okay, so do these problems. All right, pause the video, come back in a second. So here are our answers to these combinations and compositions and inverse. Okay, when we find an inverse, you switch your x and your y, and you solve for y. And then we use the inverse notation. Okay, super job. Let's see what else we got. It's over here somewhere. Ah, there it is. Oh, the tricky things. Writing a absolute value as a piecewise of linear functions. Okay, so remember how we need to write this. We need to write f of x equals, and then we have a piecewise function. If x is less than or equal to some number, and another equation if x is greater than that number. So right, this is what we call the fence back when we were actually solving these, taking our time. And we solve the fence by finding out when this is 0. So 5x plus 15 equals 0. 5x equals negative 15. So x is negative 3. So this absolute value has a fence at negative 3, right? That is the x-coordinate of your vertex at negative 3. So remember what happened when we were solving these things. The top equation was the negative of all this stuff, right? When we make it negative, since x is a positive value, right? Since 5 is positive, this is how it works. And then the normal equation just came down here. So if you have a positive x value inside of your absolute, you're simply making them both negative for the less than, and you're leaving it the same for the greater than. So let's see what that looks like in practice. Right, here is the normal, 5x plus 15. Okay, that's exactly what you see in your absolute value bars. And the negative is negative 5x minus 15. So when we come over here to do a little sketch, right, we have negative 3 is our, basically like our fence. So we're going to put in a dashed little vertical line here, but that's really not necessary. Our graph has a vertex at negative 3 comma 0. And we had a slope of 5. So up 1, 2, 3, 4, 5, right 1. 1, 2, 3, 4, 5, right 1. Okay, so here is the right side of our fence, the 5x plus 15 side. And then 5 up and 1 left, 5 up and 1 left. Here is your negative 5x minus 15 side of your graph. Okay, so putting it all together, it looks something like that. So find your fence, right? Solve your absolute value to see where the fence is. And then if you have a positive x value, the negative goes with the less than symbol, and the positive goes with the greater than symbol. Okay, you definitely have to do this on your test tomorrow. So notice if you have a positive x, or in our other example here, a negative x. Because the negative x, we're going to switch your two top and bottom things. Okay, so first we have to find the fence. We want to make it smaller. So f of x, or g of x rather, parentheses, if x is less than or equal to, or if x is greater than. So only the thing inside of your absolute value is where your fence comes from. So 2 minus 2x equals 0. So 2 equals 2x, so x equals 1. So positive 1 is where our fence is going to go. So to the left of x, positive 1, and to the right of positive 1. Okay, you always solve just your absolute value. The 5 moves our graph down 5 units. So what used to be a 1 comma 0 intercept is now a 1 minus 5 vertex. Right? We move our graph down 5 units. So there's your vertex for it. Well, let's talk about what do we put in here. Right? Notice, I hope you're noticing that we have a negative x, which means the negative is going to come down here. This is going to be the negative x because we have a negative slope. And the normal, or the positive x, is going to go up top. Okay, it switches when your slope of your absolute value, right, this is the slope thing. When you have a minus x inside of your absolute value, your two linear equations switch. Okay, so let's do some simplifying here for a second. If we take away the absolute value bars, 2 minus 2x minus 5, right, becomes negative 3 minus 2x, positive 2 minus 5. So that's the equation that goes up here. Right, the normal equation without any augmentation becomes minus 3 minus 2x, or negative 2x minus 3. also acceptable. Now what happens when we make it negative? The negative of 2 minus 2x minus 5. Okay, so only the thing in the absolute value gets negated. Right? The minus 5 does not become negative. It's not in your absolute value. So when we combine our like terms, we get a 2x minus 7 as your equation. Okay, which is good because that means we go up 2 and over 1, up 2 over 1, right? That's the slope. The positive slope is on the right of our fence, the right of positive 1. And the negative slope is on the left, as well it should be for these absolute values. Okay, so that's another way we can check to see if your equations are in the right spot. Do you have a positive slope on the right of your fence greater than, and do you have a negative slope on the left side of your fence? Okay, those are the ways that you can check to make sure that you have the correct linear equations by does your graph match up with your slope of your equations. Greater than needs to be a positive slope, less than needs to be a negative slope. Let's see, what else do we have to do then? Let's move down. Some more things there, and then some decomposition. Okay, we can handle this. There's not much left. So 2 functions, we're going to multiply them, we're going to divide them, and then we're going to find their inverse. Okay, so we'll be right back. So here are the answers to part A and B. The 6th root of x to the 19th and 1 over the 3rd root of x to the 11th. Fantastic exponent fractional stuff. Okay, so 2 more problems. The decomposition, right? We want to split this into 2 functions, an f function and a g function, so that when we compose them, we get whatever we had to begin with, the h. So remember, f is usually the parent function. So here, our parent function is something squared. So that's going to be x squared as your f, the parent function. And then g, the one that's replacing x up there, is simply 2x plus 1. Okay, B, the obvious choice is usually the best choice. Part B, the parent function could be considered just 1 over x, or maybe 1 over x squared, if you wanted to think of it like that. But let's just call it 1 over x, because then the other one would have to be x minus 2 squared. Okay, you could have also put the squared on the x and then left g as x minus 2. That would have also been an acceptable way to compose those two. Okay, so there are more than one answer to a composition question. Right, for part B down here, maybe the f is going to be the 3rd root of x. Okay, or maybe the 3rd root of x minus 4. Right, maybe we made this. Maybe that's our f. So if that's your f, that means g must be strictly x squared. So that x squared comes in here, and we have x squared minus 4. Or maybe you made this just x, and then this would be x squared minus 4, and we would replace. Right? So there are more than one right answer for these decomposition questions. But maybe not this one. So this is x to the 3/2 plus 4x to the 1/2. Right? Notice that you see the x plus 3 in here twice. That means each of these places is going to be represented by just x. And we're going to replace those x's with an x plus 3. So here is your decomposition stuff. You'll see some of those on your test tomorrow also. Okay, so hopefully that was informative, And now your brain is ready to be excellently done tomorrow, and you're going to get a fantastic grade on your first test of this wonderful semester. Okay, bye.